Welcome to the final project, step by step, which is what data scientists actually do on the job. So why is this worthy of your time? We'll explain everything each step of the way so that it actually makes sense. We don't pretend there aren't any problems along the way, because a lot of these videos people are showing, it's very contrived examples where nothing wrong is going to happen. No, the real world is messy, okay? I'm going to introduce these problems and show you the actual solutions rather than pretending they don't exist. We're going to solve a real world problem a data scientist would actually be tasked with, and we're going to use the tools that data scientists use on the job, such as Python, SQL, Spark, Pandas, Matplotlib, NumPy, and we're going to do that all in Jupyter Notebooks. It's going to be a great one, I promise you. Put a lot of effort into making it perfect. So what you need to do first, though, please like the video if you like it, or anytime throughout the video or at the end if you like the video. Please give me a thumbs up, it would help a lot. Please subscribe to the channel and ring the notification bell so you don't miss out on what's coming, because, if you like this video, you're going to want to see other ones and stay on the channel and see them pop up in your feed. So do both of those things, it's really important. Grab a drink and a snack, sit back, and enjoy, it's going to be awesome. Imagine you are the lead data scientist for a startup indoor rock climbing gym called Best Climb. Currently the gym has not been built yet, but the owner, Jessica, has a savvy business plan to make a lot of money. She offers a service where new members can do exactly one climb at the gym, free of charge. From there they can either choose to get a paid membership, or simply walk away. Jessica wants this one climb for each person to be as enjoyable as possible. Not too easy so that they're bored, and not too hard so that they're intimidated, get embarrassed, or get hurt. In theory, this would correspond to building a wall tailored to each specific person, but in reality, this is way too expensive and time-consuming. Jessica says somewhere between 3 and 10 walls is probably manageable, but this is open to change. At the company, there are 2 other employees, a data engineer, Sarah, and a veteran rock climber, Joe. You are tasked with providing Jessica both the number of walls for the construction team to build, as well as the difficulty, number between 0 and 10, for each of the walls. In the end, you need to provide a single function that takes the unique ID of a participant and outputs the wall difficulty that they should try. As a data scientist, you're an expert with working with data in general, but you lack domain knowledge in this field. The first thing you do is ask the veteran Joe, what characteristics of a person help predict an ideal wall difficulty for that person? Joe says, well, given the age and weight of a person as inputs, I can provide you my best guess as to what would be the ideal wall difficulty for that person. So you decide you need the age and weights of people, so you ask Sarah, the data entry specialist, to collect the age and weight of each person that signs up. The wall construction needs time to build the walls, so Sarah puts an ad out and gets this information for the first 200 people that sign up. Only these 200 people are able to get the free Climb Once for Free service. She stores this information in a relational database and gives you access to a notebook environment that has access to its own flavor of SQL querying, PySpark, the conventional Python libraries, and a function the veteran Joe helped her create. Okay, if you didn't catch everything there, don't worry about it because we're going to take it step by step, but just as a summary of what happened, basically you are a data scientist at this new indoor rock climbing gym company where we haven't built any of the walls yet, so we're going to have, say, 3 to 10 different rock climbing walls in the gym, and we don't know how many there are because we're trying to guess the best number based off of the people that have signed up. So from the 200 people that have signed up, which we're offering this service where they can climb one specific wall for free, so they can walk in, we'll ask them their identification number, which we'll have given them, and we should be able to output them, hey, you should climb the wall with a 7.5 rating. You should go to this wall. And so as data scientists, we have to figure out the optimal number of walls and the difficulty for each of those walls, as well as assigning each person to one of those walls. And specifically, we're actually only caring about these 200 people. We're not going to worry about more people later. So here in this notebook, which is the environment that we're saying our data specialist or data engineer gave to us, it's just a collab thing, but in there already we have an SQL database which has 2 tables. It has the ages of people and the weights of people, and we have specific functions that'll work on this database. So we can do query, and we send it an SQL-like string, and that'll return the information into a Pandas DataFrame for us. And we can also write a query and save that query to a CSV. And so we'll specify the file name, that creates a CSV for that file query. And that's useful because if our file doesn't fit in memory, or if our query that we return doesn't fit in a pandas data frame, then we have no way to load it in main memory. And so we can basically save that query into a CSV so that we can use Spark to read from that CSV. So to basically relate our file system to Spark, there is actually a way to use SQL in Spark, but I haven't set that up for you. What I have set up is read CSV into Spark RDD, which means if we have a CSV saved, aka if we saved a query to CSV with this function, then we produced a CSV, we could read that CSV into a Spark RDD, and that would distribute it across our worker machines we're pretending that we have. Something else we have access to is this expert climber, or Joe. He gave us a function which is called best climb, which takes in two parameters, age in years and weight in kilograms, and it's going to produce an integer in the range 0 to 10, which is saying his best guess as to, given the age in years of a person and the weight in kilograms of a person, what the best difficulty for that person would be. That's going to be very important later. Okay, and again, if something confused you there, do not worry about it. We're going to take all of this step by step anyway. I'm just giving a high-level overview of what we have available. Okay, and before devising a specific solution path, let's just start visualizing the data, see what we've got available to us, and then after we do that, maybe we can talk about a specific solution that a data scientist would talk about. So first, it almost always is going to start with our SQL table, okay? So we have this database, we have two tables, ages and weights. So let's go take a look at both of those. So to do that, I have this query function. It's going to put it in a pandas data frame. I should be able to do that just fine. Let's start at looking at the information in our ages table. That's the one listed first, and it's alphabetical. Let's just start with that. So we should be able to write query, because we have this function available, query, and then this is an SQL string, so we'll select star from ages. We just pass in the string like that, and if we output, then we see, yes, this is a pandas data frame. We can tell by looking at it. If you wanted, you could write type of this thing and it would say pandas data frame, but here we have an ID column. Don't worry about the index over here, this column. We have an ID column, and we have an age column, and yes, as expected, we have 200 different results. Remember from before, we're trying to assign each person to a hill difficulty of these 200 people, so we took only the 200 that signed up first. And so here we have their ages, and I guess they're using different systems to store the ages and weights because the weights information is in a different table. Okay, so now that we've looked at this, that looks good. Let's just copy this and try and do the same for weights to take a look at that. We have an error. Pandas memory error. File is too big to keep in RAM. That's kind of odd because we should have 200 rows and it should look something like this where we have ID and then weight. I'm surprised we can't fit 200 rows of weights, but what can we do to solve that? Well, I guess we'd have to use Spark, because if you read it into an RDD, you could actually distribute this information like an RDD. It stands for Resilient Distributed Dataset. So if we distribute this file across our network or our worker machines, then we're able to keep it in main memory and process this thing. So, okay, and again, before anyone gets scared about using Spark, please don't turn off this because you're scared of Spark. It's really, really simple, and if you've never seen it before, then maybe you could watch my video on it. You don't have to, just watch this. It's not going to be difficult, okay? We're going to take it step by step. So to read our information into Spark, we have this read CSV into Spark RDD, given a CSV file. So first we have to actually generate the CSV file. Luckily we have this save query to CSV given an SQL query string and file name. So what we can do down here is save query to CSV, which is a SQL query string. So we can actually just copy this right here. And then whatever we want to call the file, let's call it raw weights.csv. Okay, raw meaning we haven't really touched it at all. It's just right up saving the file there. Okay, so we save that here. Let's take a look over here. Ignore most of the stuff. This is our database. This is Spark, some other stuff. Here's the information we actually care about, raw weights.csv. So we can tell we saved this information, and now we can open it into a Spark RDD because we have read CSV into Spark. And so we will write read CSV into Spark RDD. That takes a file name, and the file name is going to be right here. So again, I'll just copy that. Okay, and then if I output that right away, okay, right, it's an RDD, and the reason it's not showing me any information is because, remember, if it's Spark, we're distributing our information across different machines. So the information is not on this machine that we're calling the program on. It's distributed away from it. So if we just print it, it's going to say it's an RDD because that's what it is. But we can still save this into a variable. So we'll say RDD or weights RDD. We might have multiple later, so let's say that weights RDD is equal to that. And what we can do is call take, which says, give me the first 5 rows of this data. So we're distributing raw weights.csv into an RDD across different machines. Now let's take the first 5. All right, and there they are. The first is a header, and the next 4 are actual data. And as we see, it is actually keeping it as each entry is a list of strings. So the first one, they're actual strings, which is the header, but the next ones, they are data, which are just converted to strings. So clearly the ID should be an integer, or you could keep it as a string, or the weight is definitely a floating point value. Okay, so let's first just try and look at the data itself. We don't really care about what the header is. It's just nice to see what is in there. So let's first look at the data, which is the way we can do this is data is going to be this weights RDD, and we want to filter, which means we want to only keep certain things in the RDD. And the easiest way to do this is, so you pass it a function, which X is always going to be, it's saying, do we want to keep this? So filter's saying, do we want to keep this row? Well, I only want to keep this row. By the way, a row is a list of strings. So we only want to keep it if x0, meaning the first item, if that is not equal to ID, so then it wouldn't take this row because that is equal to ID. It would keep this row because 0 is not ID, 1 is not ID, and hopefully all of the other data is not. Okay, so that first filter them, and then I can show you what that produces. Okay, so as expected, that removed the header, except all of these data is still strings. So let's actually map it to, meaning we want to do something to each of the rows. We want to map, where X is a row here, and so it's a list of strings. We want to return, let's actually make it a tuple. It really doesn't matter. Instead of a list, we'll make it a tuple. And we want the integer of x0, because remember x0 is this first value. If we convert it to an integer, that's what we want. And then the second element of this tuple is going to be the float of the second part. Okay, so that's just converting the first part to an integer and the second part to a float for all of the values. And if I just take that, then it's going to be all the data, and it looks really good. Right, so nothing looks fishy about this so far. Remember why we're using Spark is because this wouldn't fit in main memory. It was too big to fit into a Pandas DataFrame and RAM. And so nothing looks wrong so far. It looks like we have, one item for each ID. We have an ID and a weight, an ID and a weight. It looks fine. Let's just see how many rows we have, because we're supposed to have 200 rows because we have 200 people. So let's show data.count, which is just the number of items that are in my RDD. Whoa! Okay, we have 20,000 of them. Something's wrong there. So do we have 20,000 people? Let's see how many we have for each person. So basically for each ID, how many entries do we have? Because right now it looks like we have 0, 1, 2, 3, 4, and there's only 1 for each. Let's make sure that there's only one occurrence of each ID, meaning we have only one weight for each person. Okay, and the way to do that easily is just through a group by. Remember, if you watched my Spark lecture, you'll know that group by can actually be scary if there's a lot of information. So if this took super long, then we'd maybe cancel it and try to do something else like a reduce by instead. And if you don't know what I'm talking about, either don't care or watch the video. I'm just saying group by can be kind of slow. But right now, let's try to do a group by, which is basically going to make absolutely certain that there's only one ID per each thing in the RDD, except what it's going to do is group all of the items. So if it has actually looked like instead 098 and then 042 and then 050, it would actually have 0 and then all three of those values I just said over here in like a list or an iterable. We'll see what it is in a second. So to do a group by, it's actually very easy. Well, I can say grouped by ID is equal to our previous RDD dot group by key. Okay, so we group by the key meaning, this ID, the ID is the key. And if I do that and we take 5 of them, okay, so show me 5 of the results. We have, okay, don't worry that it's showing only the even numbers, it's just the way that take is doing it. It's not like we got rid of the other IDs there. Okay, and I'm sure this result is kind of confusing because we have an ID and then this really weird thing. The point is that it's an iterable, okay? So it is a list of stuff. It's just we can't really view it in this form. So what we can do is just look at the length of this thing. So if it's an iterable, meaning we can loop through this thing, say if the values were 5, 10, and 12, we could loop through it and get first be 5, then be 10, then be 12. Now, this thing has a length, okay? It's a bunch of items. So what we can do is actually basically get the lengths RDD. So the lengths per ID basically. So the lengths for each ID, we're going to have the length of this thing, and that would be the previous thing. And then we want to do is map because we want the ID. So for each row, we want that same thing, that same ID. X0 is the ID. This next thing, x1, is the iterable. So if we get the length of x sub 1, that will be how many items are in this thing. Okay, and let's just output a bit of that. Maybe 5 of them again. Oh my. Okay, so what we were really expecting is 1, because, we should have had 1 weight per person. I don't know why people would have multiple weights, but for some reason the data in our table is saying that for person ID 0, there's 100 weights corresponding to them. And for each of them, actually, each person has 100 weights. And actually this makes sense with the math, because if you do 100 times 200, that does output 20,000, meaning for each of our 200 people, they have 100 weights each. So that's why it's too big to fit in main memory, is because we, for some reason, have 100 floating point values per each. So let's investigate that a bit. Okay, so instead of taking the length of this thing, let's actually do something very similar, except take this information, so grouped by ID, except let's map not the length, but let's map, so we still want the tuple of the ID, and then right now this, remember, is this tuple, or this is this iterable thing. Okay, I'm not using the lengths one here. So how can we visualize this thing? Well, we can actually just call list on this thing. So if we do list of that iterable thing, then actually let's just take, so we're not going to store this in a variable. I don't think we really need it. We'll take, say, one of these things because it's going to output a lot. Watch this. Because we have the ID of it. So here, the ID of 0, and it has these 100 weights. So let's look at these things. It looks like they're all roughly close to each other. There's nothing weird. I'm actually going to call Sarah, the person who got the data, and try to understand what these numbers mean, because just looking at it, I really can't figure it out. Hey Sarah, how are you?
Hey Greg, I'm good. How are you?
Good, thank you. So I have a question about the data, if that's okay.
Yeah, go ahead.
Okay, so I'm looking at it, and right now I can't see all of it because it's not fitting in main memory. For the weights, I'm looking at each ID, and it actually appears as if there's 100 values per ID rather than just one. I would have thought there was just one.
Oh, right, yeah. So the scale is a bit messed up, and so it actually produces 100 different values for each person instead of just the one.
Oh, okay, yeah, that makes sense with what I'm seeing over here.
I'm so sorry for the trouble.
Oh, no, it's fine. Okay, so have a good day, Sarah.
Thanks, you too, Greg. Bye.
All right, see ya. That makes sense. So basically, she said that the scale produces 100 values, and it looks like they're all good values. So I think we can just average the results so that we get one value, so then we can go back to 200 rows. So let's do that. Firstly, this is way too much output, so I'm going to kind of remove this. I don't want to see that. Okay, so now what we can do is basically call this thing called averaged weight RDD. Okay, so it's just going to be this grouping thing, except since we've already grouped it, all we have to do is just take the average of this thing. So what we can do is grouped by ID dot map. So we want to apply this function, which again keeps the same ID. We don't want to do anything to the ID, but we want to compute an average. And so to do that, we can just say the sum of x1 and divide that by the length of x1. All right, so sum up these values and divide by the number of them so that we compute the average. And then if we take a couple of values of this thing, it should just be nice ID and weights as it is. Now we should have only 200 rows, so just to make sure, we should do a count. And yes, we have 200 rows, so that's perfect. So now we want to combine information. So we have this weight RDD, and this information is going to fit in main memory in our pandas data frame because it's down to 200 rows now. It's small enough to fit. We saw the ages one fit. 200 rows is pretty easy. So we want to somehow combine the weight and age information and keep the ID so that for each given ID, we have that person's weight or averaged weight and their age. Okay, so it should have ID, age, weight all in one row. Okay, so those three columns. To do this, there's a couple different methods, but what I'm going to do is first convert the age table into an RDD, and then we can join the RDDs. So let me show you that. So the process is going to be very similar for now, which we did with the weights, sorry for the big jumps. We have save query to CSV, this weights thing, okay? So that's how we got it into a CSV, and then after that we did read into an RDD. So first we're going to do this, except we're going to select star from ages, and we'll call it raw ages.csv. So that'll just query the database, put the information into the raw ages CSV, and then we can do what we did before, except open up a ages RDD. So very, very similar. I'm going to put it all in the same cell. So weights RDD is read CSV to Spark RDD, the raw ages.csv, and I'll call that ages RDD. Okay, so there we go. We'll take 5. Here we go. Looks very similar. So same as before, and I'm going to do this pretty quickly because it's basically the exact same thing. We're going to convert the types into what we want and get rid of the header. So here this is going to be an integer. The ages are actually integers, so we're going to make those integers too. Okay, so just to do this quickly, we don't want the header, so we're going to do a filter where we do ages data, we'll call it. Ages data is equal to the ages RDD dot filter. We don't want anything that has the first value equal to ID. Okay, so we want to keep whatever is not ID, meaning this one, this row, this row, this row. We don't want that first row. And then we're going to do a map, which produces, basically it converts each of the strings to an integer. So it's going to have the two tuple of, it's going to be the integer of x0, and it's going to be that's not right, the integer of x sub 1. All right, and then if we call that, we do ages data dot take, say 5 of them, and that produces what we want. Okay, so now that we both we have both the weights and ages in an RDD, we're going to do an RDD join based off of these IDs. And that's the same kind of join as we made in SQL, as in, you're merging values based off of some key or ID field. So here, the key or the ID is this first value in the ages, and it's the same for the weights. And so we can merge, say we want this 0, we want it to be 0, 30, and then 98, and then 1, 49, 73, sorry, that's actually 1, so it'd be 2, 49, and 73 here, and there'd also be 1 for 1 as well. It just looks kind of weird there. Okay, so we can do joined is equal to ages data dot join. It's just the same as an SQL join, and we're going to pass it an other RDD. So we'll pass it the averaged weight RDD, and then joined dot take 5 produces this RDD. You see here it's with the ID, and it grouped those values together. So it's now in the form of an ID and then a tuple of the information between the two RDDs. So ID and then age and then weight, except we want to format that a little differently. So we'll just have map lambda x, which produces still the ID, except then the second element is actually a tuple. So what we want is basically just to flatten it, so to put it all in the tuple, get rid of this tuple piece here. And so what we want to do is just x1, which is a tuple, and then we want the first thing, and then we want x1 sub 1, or the second thing. Okay, and that is going to put it in the format that we want of ID, age, and then weight. So this is the data that we want, but it's in this RDD, which is distributed. We want to put it in main memory so that we can do stuff like graphing on it. And yes, you can do stuff like this in Spark, but let's just pull it out of Spark because we can do all of this in Pandas much easier. It's going to be less complicated if it's not distributed anymore. There's no point of distributing it, really. So we can do what's called a collect, which means pull all the information into a Python list into our main program. So we can do collected is equal to joined.collect. So collected is now a Python list of these tuple objects. It's going to look very, very similar, but it's not distributed. So my notation is now collected for the first 5. So that's saying 0, 1, 2, 3, 4, the first 5 rows of this Python list. And now it looks printed exactly the same, but it's not distributed. It is actually a very different concept. So from here, we can actually convert this into a pandas data frame very easily, and let's call it just good pandas data frame. It's the information that we want to have. It's equal to, if we do, actually I think we need to import pandas. We haven't done that yet. So let's import pandas as PD is the convention, and then we'll say good pandas df is equal to pandas.dataframe. So we're just constructing this data frame using our information, so we can just pass it this Python list. It's comfortable with this type of object it's in, this list of lists basically, or list of tuples, doesn't matter. So it's collected, and then columns, we pass it the names of the columns that we want, because remember this is just the data. So if we pass it a Python list of names, this is columns is equal to ID, and then we'll call it age in years, and now the last one is the weight in kg. And so good pandas data frame, we don't have to write take anymore, which is nice. We just output this, and pandas knows how to output this kindly. Okay, so it's back to what we had in the beginning, except the information is combined. We have 200 rows by these 3 columns. It is nice. At this point, we actually have something that we can go ahead and save our work, because of course we're going to work in main memory still. If we wanted, we could maybe switch notebooks to clean it up, but we're going to keep all the information here anyway. I'm just going to save this data frame so that we can get it back easily. So we don't have to use that Spark nonsense anymore. We're gone with it for now. So we can write good pandas df dot to pickle is the easiest format, to pickle, and then we give the name, which I'll call ID age weight combined dot pkl. Okay, so that's just saving that file. We'll see over here that yes, it does show up right here. Okay, so we have that saved, and then just to prove that it works, we'll read it in, call it the same variable name, and we'll say pandas.read from pickle, read pickle. And that same name, I'll just copy and paste the name, and outputting it again. There we have it. The exact same thing, it's just saved, so we don't have to use Spark again. Alright, so next up, let's actually investigate our data. We couldn't really do this before because our weights were messed up, and maybe I should have called this average weight because it's an averaged weight, but whatever. We're going to use that as our weight, so that's fine. Let's look at the data, and we'll do all the conventional pandas stuff that we would to look at the data. So we'll do good pandas df dot hist. So we'll make a histogram or a frequency count for each of the variables. So you can see ID has what's basically a uniform distribution, meaning that there's one of each different ID. That's good from 0 to 200 or 0 to 199. Age in years, there's some distribution here, kind of uniform, kind of trimodal almost. There's like 3 different values, groups of values that are more than others. There's lots of values between 0 and 30, lots between 30 and 40, lots between 50 and 60 or so. Weight in kilograms, same type of thing. Actually, it looks like there's a lot around 60, there's a lot around 75, 80, there's a lot around 90 kilograms. Okay, so that's just for fun, look at the histogram, see if there's anything interesting. We don't see any negative values, that's good. Another common test we can do is not histograms, but instead we can do basically a summary information. So we can call it describe, is what it's called in pandas, which is just getting some information for all the variables. So there's 200 of each, that makes sense. The mean ID makes no sense. The mean age is 37. The mean weight in kilograms is 77 kilograms. That sounds about right. There's a fairly big standard deviation, so a lot of variation from the mean, which we can kind of see from these histograms here. It's not so clustered around these middle values. So remember, 37 is this value. So there's a lot of standard deviation. As you can see, there's a lot going on that's away from this average of 37. And same for the weight. Okay, so then we can look at the minimums. Minimum age is 18, minimum weight is 51 kilograms, so that's about 110 pounds or so. That makes sense for climbers. The maximum is 58 years, yeah, and the highest weight is 105 kilograms. Okay, this all makes sense. So let's do a very simple graph which just scatter plots the data. So we can use matplotlib for this, import matplotlib.pyplot as PLT, and we'll reference our columns, or our series basically. So I want a reference to this column and this column. I'll say ages is equal to this good pandas data frame sub the age in years, and I'll have weights is equal to that same thing, weight in, why is it not coming? It's not coming up. Weight in kg, that's fine, that should still work. And we can do a scatter plot, so plt.scatter of the ages and the weights. That should work just fine. Okay, so we don't have any axes, but the one on the x is age, the one on the y is weight, and it's just a weight versus age, not histogram, scatter plot. Okay, so let me just look at this a little better. I said we don't have the axes in a title. Let's make an axes in a title. It makes it a lot easier that way. So let's just get an X label, call it age in years, and a Y label. So we'll do weight in kg, and then the title is really just the weight versus the age of the 200 climbers. All right, and now we have labeled axes and titles. It looks good. Okay, so to me, something very interesting stands out that we can use basically directly to solve our problem. If you remember the things that we have access to a guy named Joe. And this Joe says that if you give me the age and weight of a person, then I can output the best difficulty hill or climb for that person. So, looking at this data, it actually looks like each of these people kind of belong to a certain group. And we know nothing about this group other than, approximately what their average age is and their average weight is. So to me, I see one group of people here, one here, one here, one here, one here, and one here. Okay, so I see 1, 2, 3, 4, 5, 6 different groups of people. And what we can do is actually find basically this average value in the middle and assign each of the people to the groups to basically saying, hey, you are in part of this group and your average or your group average is this middle value here, which is the mean age and the mean weight. So what I'm describing is actually what's known as a clustering problem. And I didn't even really know we wanted to do this until we looked at the data and saw it's so obviously groupable. And yes, we might have been able to do this even if we didn't see this, but if we do see this, it's very clear to me that we can just get the mean of each of the groups and then ask Joe, hey, given this mean group, so given this age value and this weight value, get me a wall for that group of people. And so then all of these different people would have that go to that same wall. And same with these group of people, they would go to their own wall, where if we asked Joe, hey, given an age of about 40 years and a weight of about 60 kilograms, what wall difficulty is good for them? And all these people would be assigned to that same wall. And all these people would be assigned to a wall, all these people would be assigned to a wall, and every single group would be assigned to the wall where the difficulty is based off of their mean age and their mean weight. Now, how do we solve that problem? It is a clustering problem. So the next part, if you haven't seen my video on the Kmeans clustering algorithm, I'll link it up above and maybe you could watch that. But honestly, the math isn't very important here. The only important part is the idea is that we're going to assign each of these people to a group and then get their mean for each of the variables, so their mean age and their mean weight, output Joe's function, so input the age and the weight, get the hill difficulty or wall difficulty for these people, and then we can assign each of them to that wall. It doesn't really matter the math too much. I think it's important to understand it, and I'll link it up above. But if this part, a little bit of the math goes over your head, that is actually okay here. What we're going to do is use scikit-learn's K-means clustering algorithm. And if you haven't seen it before, well, you're going to see it here for the first time. So the first thing we have to do is get our information into just the variables without the ID field in a NumPy array. So I've said in previous lectures that you use NumPy when you want to do stuff slightly more complicated. And this is a little bit more complicated with the K-means stuff. It's not simple summary statistics. We're going to be performing really numerical computation, or scikit-learn for us is going to perform this numerical computation. So we're going to put it into a NumPy array. So the first thing we're going to do is say prepared data is equal to the NumPy array. And if I haven't imported NumPy, I'll do that again. Import NumPy as NP. And then prepared data is this NumPy array of the, what do we want? So we really want the ages and the weights. We already have these things. These are pandas series, so I know it's kind of confusing, but watch what this does. So prepared data. If we output what that is, it's not quite what we want. Let's look at what's called the shape of this thing, which means basically the organization of the data. So it means there's 2 rows and 200 columns. So that would mean that the first row is 100 values and the second row is 100 values. That basically means the first row is all of the ages and the second row is all of the weights. Now we don't really want that normally. We want it as each row is like one data point, and one data point would be like an XY, and then the next would be an XY, next would be an XY. So really we want to what's called transpose this, and I'll just show you exactly what it does with this. Is it makes it so 200 rows, so each row is a data point, and each data point has two features, their age and the weight. So if I do prepared data and I show you the first 5 rows, what that is then, hey, this is the one data point, it has 30 and 98, so it would be probably 30, 98. It would be one of these 2 points, I think this point, and then 50, 76, it's going to be probably this point, and so on. So now we have our data in a format that scikit-learn is going to like. It's in a NumPy array of each row is a data point. So now let's go ahead and import scikit-learn's clustering Kmeans clustering algorithm. And Kmeans is just a particular clustering algorithm. And the only thing you have to know about it right now is that it's going to ask us how many clusters there are. And when I say cluster, I just mean group. I mean group of information. So this is a cluster. This is a cluster. This is a cluster, 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 cluster. I can tell that just by looking. There's ways to do it without looking and doing it just mathematically. But we can look right now, since we have two-dimensional data, and just say there are 6 clusters. Okay, there's going to be 6 groups. So when I import from scikit-learn.cluster, import Kmeans, I'm going to make a Kmeans model. Sorry, Kmeans. And then I'm going to make a Kmeans model, which is equal to Kmeans, so that thing we imported, which asks for a number of clusters, n clusters, which we'll set equal to 6. Okay, so we have 6 groups. We're telling it that. We know that. So then what we do is call it fit. So that's basically saying, run the model, actually produce the information that we want, which I'll show you after. But you know what it's going to do is definitely assign each of these to the same group, at least hopefully. So these will be some group, these will be some group, these will be some group. And for each of those groups, we should have the mean of those groups. So K-means 6 means. The 6 means are going to be this value, this value, this value. All these centers for each of the 2 variables. So the center here for each of the groups. So it's going to produce both the point which group it belongs to and the mean for that group. So if I call fit on this thing and I pass it the data that it enjoys, we're going to get, well, first off, let me show you the cluster centers or the cluster means. So cluster means is equal to the K-means model dot cluster underscore centers underscore. It's kind of weird. Let me show you that. Okay, so here we have 6 values. 1, 2, 3, 4, 5, 6. We have 6 values. That makes sense because we're asking what are the means for each of the groups. So this mean 39.9 and 59.8. Well, about 40 and 60. 40 and 60, that would be the mean for this group. And if we have 34 and 79, that's 34 and 79. Sorry, 34 and 79. It's right there. It's the mean of that group. And so we have each of these rows represents the mean for each of the clusters. Not only do we have that, we actually have the which point belongs to which cluster. But right now, let's just plot this information that we have right now. So I'm going to grab the same information from before. We might not need all of this, but I'm going to keep it in the same spot just to make it easy. Now the only thing I'm going to do differently is scatter it. So plt.scatter, scatter the cluster centers. Okay, so if we do scatter cluster centers, or I called it means, cluster means, and then this part's kind of weird, so we want all of the x values here, which this is all of this information here. So it's actually cluster means colon and then 0, meaning all of the rows, so all the rows, and then the first part, so this column. It's basically saying the first column, and then all the y's are the cluster means, all of the rows, and then the first column. And now I'm going to make this make it sure it's visible. So we have color is equal to green. And then this is just a size. So let's go with 100. And if we output that, check out what it does. It's the exact same graph before, except what we just added, which is the mean for each group. So it put this green blob in the middle saying this is the mean value for each of these groups. And although I haven't shown you yet, it has assigned each point to this group. It knows that this point, or these points, belong to this mean, and they're all part of the same group. So now let me show you something. Actually, first let me just show you that this thing exists. So it's called labels is equal to Kmeans underscore model dot labels underscore. And labels is this one-dimensional NumPy array, which is basically just saying that for the first data point, it belongs to cluster 3, and this belongs to cluster 5. And if you're asking what the numbers are, they mean absolutely nothing other than they're the same. So it's saying that these two points, the first and the third point, they belong to the same group. And the second and fourth point, they belong to the same group. And that order matches the same as what we put it in as. So, sorry, I went a little too far there. What we put it in as was this order. So this is the first point, and then this is the second point. So we said that the first and the third point belong to the same group. Well, 30 and 98, 24 and 95, yeah, those values are pretty similar. If we look right here, 30 and 98, so this value, and 24 and 95, yeah, it's like one of these values. So they do belong to the same group. That's all these labels are saying, is just which point belongs to what group. And the value is just, these are the same group. If they're the same number, that means it's the same group. So the first thing I'm going to do is just add this information to our data frame. So I want the same pandas data frame as before, this thing, except now what we actually did is assign to each of these points, we assigned a cluster. So I want to add this group right there. We can do this pretty easily with, I'm just going to call this something different for fun. Pandas data frame, final panda data frame is equal to what we had before. And then final pandas data frame subcluster. Okay, so I'm making a new column, calling it cluster. And I'm setting that equal to, it needs to be a series. So we'll set it to the pandas series of the labels. Okay, so it's just saying, adding this as a column, basically. This is 200 values, and I could prove that to you with labels.shape. It's 200 values, and so if we turn that into a series, then this is just adding that value, or that cluster, to that value, saying which group each point belongs to. And then if I output this thing, final pandas data frame, that is just saying that these points belong to the same cluster, first and third, and then these ones belong to the same, and so on. Okay? Now, what else do we want to do? Well, we want to produce kind of a more interesting graph, because right now I don't really know what each of them belong to. This one could have been assigned to either one. I actually have no idea. These ones it probably would have got, these ones it would have got. But some of these middle values, like what are these? Which ones do these belong to? And of course, you could manually look at each one of them and figure out which one it belongs to. But you can do this all in one graph where I color each of the same points a particular group color. So we're going to have 6 colors because we have 6 groups. I want each point to be one of 6 colors, where that color represents the group for that point. And now again, I said before, for slightly more complicated stuff, this I would say is slightly more complicated, we often want this into NumPy. So let me grab final, I'll just say final as NumPy, or NumPy array. Final as NumPy is equal to the final pandas data frame dot toNumPy, so that just converts it into a NumPy array. And let me show you the first 5 values of those so that we're all on the same page. Sorry, that's not the right thing. final as numpy. And now, if we have it like this, basically what we can do is get the same graph as before, except add these colors in. And we only need some of these values, so I didn't really need to convert the whole thing into NumPy. We're only going to need this value, and this value, but that's fine. We can select that manually. So this part's a little bit confusing of a graph, but I'm going to step through it slowly, so hopefully this makes sense. Graphs like this, that's everything in data science if you can produce stuff like this. So I'm going to produce, actually let me grab this one. I want the cluster centers there too. So here's the exact same graph, except we need to add the color for each of the points. So what I'm not going to do is scatter all of the ages and the weights. We don't want to do that. And actually, we're not going to need these either, because we are going to use the information from this final as numpy thing. So first, I'm just going to get colors for each of them. I'll say the first color is going to be brown, and that would correspond to whenever you see a 0 here, cluster 0, if I reference this thing, I index that by whatever value this is, that would produce that color. So if I have cluster 0, that would produce brown, because brown is the 0th or first color. And if I had 2, well, let's see what that's going to be. I'm going to make the next one blue. And this is just arbitrary. You can really choose whatever you want here. I'll choose this to be red, and then so we'll say these for 2, that would be red. Okay, so each of these is going to dictate the color, because we want each point or each group to have the same color. That's the point of our graph. So now just to produce a couple other values over here, or in a couple of the colors, we'll have yellow, orange, and purple. Okay, those are our 6 colors. Now, this part is again a little bit confusing. I'll step through it. So I'm going to iterate through each of these points, and I know they're not really points, but this is a point, the X and the Y, and this is the cluster. So I'm going to iterate through this thing and say for row in this final is numpy thing. So each time row is, a row of information. It's one of these things. So what are the things I want? Well, I'm going to call it X is the row sub 1. So X is this value, or this value, and Y is row sub 2. And I'll just say the label is equal to the last thing of the row. Okay, so I'm just saying X is this thing, Y is this thing, label is this thing. X is this thing, Y is this thing, label is this thing. So now that I have those 3 nice and easy, I'll say color, which is going to be a string. Color is our colors array, sub the integer of the label. That's what I was saying before, is we're going to index this colors by this group here. So if we get 0, if the label is 0, then it's going to input a 0 in here, and it's going to say color sub 0. That means you want brown. So that way each group has the exact same color. Now I want to plot this point, and so I can just do one value at a time, and maybe not the most efficient. There might be better ways to do this, but this one works for the data that we have. We could do plt.scatter x, y, and then set the color equal to whatever color we have, and that should work. There you have it. So we put each group a color. We gave each point a color indicating which group it belongs to. All of these belong to the same group. All of these belong to the same group. And the groups mean nothing other than these points are very similar. Okay, they all belong to the same group just based off of how close their values are. And I guess this blue one got to this one, but this yellow one's got to that one. That's fine. Okay, and there's actually more complicated ways to do this Kmeans thing a little bit better, except this one, honestly, it worked just fine. So we're going to stick with it. We have this beautiful graph, and we've assigned each point to a cluster. We know that we're happy with the results. Now, why did we bother to do this? Okay, I know that we went down a bit of a path here where we're just kind of doing stuff, not really thinking about it. We said a while ago that we wanted to cluster each point, meaning we want to assign each point to a group and know both what group that point belongs to, as well as what mean it has. So if I know the mean associated with this point, and this point, and this point, I know what this value is for each of these. The reason we're doing that is because we don't want to make a climbing wall for each individual person. Of course, if we had 200 points, we could just ask Joe 200 times, what do you think is the best wall for each of these people? But that potentially does produce 200 different walls. Our manager, or the owner, Jessica, said, no, we need somewhere between 3 and 10 walls. So here, 1, 2, 3, 4, 5, 6 walls, that will do just fine. And we know that they'll be happy with that wall, at least they're likely to be happy with that wall, because they're close to that point. They all belong to the same group of people. And of course, do we know for sure that that's right? I mean, we trust the variables because the age and weight, that's what Joe said. It may or may not be right, but we're assuming that it's right based off of what he said. And we did this grouping algorithm so that we know, these all belong to the same group. There's not really anything else we can do other than try other variables, but we're going to assume that we're happy with this. This is fine. Okay, so now what our complete end goal is, we've done a bunch of things. We've said that we want 6 walls, and we've basically said each person belongs to a certain wall. Now what we need to do is actually compute the difficulty for each of the different groups, and we can do that with this nice notation, which I'll show you. We can build a list like this. So if I do x for x in range 5, what that would do is produces this list of 0, 1, 2, 3, 4. We could do something very similar where we call best climb many times. And just to remind you what best climb is, this is Joe's function. Okay, so Joe said, given the age and weight of a person, we can ask what the best climb is, and it's going to produce the difficulty for that age and weight value. But we're only going to do it 6 times rather than 200 times because we know that we want 6 walls now because we found there's 6 groups. So since we have the mean of each of those groups, we'll just call it 6 times for each of those values. Okay, so if we do best climb of, I can write it like this, best climb of xy for xy in the cluster means. Okay, if you remember what our cluster means are, they are these things right here. Okay, so each of them is the group. So this is the mean for the first group, the mean for the second group, and so on. Okay, so if I call that 6 times, it's going to do it for each in the cluster means. Then what that would do is produce the value for each of those cluster means. So for the group sub the 0 group, it's going to be 4.6, and for the 1 group, it's going to be 4.92. And we know this by color as well. So we can look back and see what our colors are. We have colors equals brown, blue, red, yellow, orange, purple. So each of the brown points are going to belong to this group because of that, or they're going to have that difficulty. All of the blue points, all of these people, they are going to have this difficulty. And that's just based off of what Joe said. Okay, we're trusting that he said what he said was right. All right, so now we have, for each of the points, we have the best climb for each of those people. We know we have 6. The last thing that we have to do is be able to compute this very quickly. So just so that we have all of this information together, we're going to make this new pandas data frame, correct climbs is our data frame from before, which is the one with the clusters. We have this. We can actually do an apply, where this is basically making a new column. So it's going to do apply on this column. And if I pass it a lambda x, this is saying, let me actually go back for a second. So it's saying this column, okay? We're referencing this column and we're saying apply. And so it's going to produce a new column or series object where if we do this lambda x, the x is referring to this thing. And so whatever we return from that function is what we want for that new value. So if we did apply with x lambda x squared, as in we want the square of x, we'd have a new column that did 9, aka 3 squared, 25, aka 5 squared, and so on. We're just applying some function to this. And the function that we want to apply is basically, well, we already have this thing over here. If I call this thing maybe climb difficulties, okay, so climb difficulties is equal to this thing. We'll run that again. And let me just output that so you can see it. Okay, so if we call that this thing, then what we can do is actually just return that object, so climb difficulties, sub x. Because remember what x is, it's the cluster label ranging from 0 to 5. So if the index or the cluster label is 0, that would mean, hey, we want the climb difficulty for the brown group or the 0 group. We want this value. So if I output this thing, you'll see the first one is 3.2, so 0, 1, 2, 3. So that would mean that the first ID, or the first thing in our first point, that one had a cluster label of 0, 1, 2, 3. All right, and if we look back, we say, yes, we see it here, we see it here. This ID had a cluster label of 3, and therefore we wanted the associated mean value, or the climb difficulty from the mean values of the cluster right here. Okay, so now just to add this to our main pandas data frame, we can have not just the cluster, but also the best climb. So I'll say final pandas data frame sub the best climb. So making a new column called the best climb. And we can set that equal to exactly what we have right there. And if I output it, there you go. So for each, you can see for each of these clusters, they're going to have the same best climb. That makes sense. Okay, the very, very last thing that we have to do, our manager asked us, we need one function that, given the ID of a person, we have the best climb value for each of them. Okay, so that is just querying this database, or this pandas data frame. We can write that very easily by this function. We'll say, hey, call best climb, and maybe in practice we might make this production a little bit better, but here, this is quite fine. We're going to define best climb. We'll say given ID, okay? So the best climb, given the ID, is going to be the ID, and we'll set the default. If you don't know what I'm doing here, that's perfectly okay. I'm just setting the default value of df to be the final pandas data frame, so setting it to this object by default. And now we're going to return the data frame where the data frame sub the ID is equal to the ID that we gave. So that's inside here, it's querying our data frame ID column. So we ask what is the ID, wherever that ID is equal to that ID that we asked for, we want the data frame sub the best climb. That's the actual value that we want. Okay, so it looks for the right row based off of the ID, and then the actual value that we want from the data frame is the corresponding best climb. All right, so there we have it, just to show you that it works. If we ask what is the best climb given ID of, say, 4, we get a value of 8.78, meaning we have an ID of 4. They got assigned to cluster 5, and the best climb for that group was 8.78, so that's what we returned to them. So there you have it. We are done. We did everything that management asked us to do. We gave a number of clusters, or to them, it's the number of walls that we want. Okay, so how many walls do we want to build? We want to build 6 walls. We decided that based off of the number of groups from the variables that Joe told us were going to be useful. Okay, so we saw there's 6 groups. We say, hey, build 6 walls. They want to know what difficulty of wall for each of them. We're saying, hey, give us a 4.6 wall, a 4.92 wall, a 7.45 wall, 3.2, 9.5, and an 8.8. Build these 6 different walls. We can't build one for every person. Build 6. And so each of these people go to this wall. Each of these people go to this wall. Each of these people go to this wall. And we can say which wall it actually is with this function. So we wrote it at the bottom here. We query our table, which says, hey, just given the ID, and so if the person walks in, they can say, hey, what's your ID? Okay, this is my ID, and we'll tell them what their ID is. What's your ID? Okay, if you have an ID of 0, your best climb should be 3.2, because that's what we figured out way beforehand. All right. Again, if you liked today's video, please subscribe to the channel, ring the notification bell, like the video, all that good stuff. I'd really appreciate it. Have a good day. Thank you so much.